Hello everyone, welcome to the next tutorial. In this tutorial, we are going to solve some problems based on the basic concepts of your network theory. Okay, so this is your first question. In this, we need to find the value of Vs. Okay, so we need to find the value of the Vs and the electrical circuit over here is given to us. Okay, so let's say a current I is flowing from 1 ohm resistor. Okay, so on applying KCL on this particular node, we can see that 12 amperes plus 0.6 V1 is equal to I. Okay, so this is your first equation. Okay, also we can see that by applying the current division principle, we can find the value of this particular I naught current, the value of the current I naught by using the current division principle. So I naught will be equal to, the total current, which is equal to I, okay, into 5 divided by the total resistance, which is your 2 plus 3 plus 5, which is your 10 ohms, which is equal to, so I naught is equal to I by 2. Okay, I by 2. So this particular dependent current source is dependent upon the voltage V1. Okay, so by applying Ohm's law, we can find the value of the V1 over here. So by applying Ohm's law, we can say that V1 will be equal to the current I naught into the resistance, which is 2 ohms. Okay, so V1 will be equal to I by 2 to 2. So V1 will be equal to your I. Okay, so we will substitute the value of V1 in this particular equation 1. So it means that the value of I will be equal to, so I will be equal to 12 plus 0.6 into your I. So it means that 0.4 I will be equal to 12 and I will be equal to your 30 amperes. Okay, we can also find the value of I dash, that is the current flowing from 5 ohm resistor. Okay, so again, on applying KCL on this particular branch, we can see that I will be equal to I naught plus your I dash. Okay, I naught plus I dash. So I dash will be equal to I minus I naught. The value of I is equal to 30 amperes and I naught is equal to 30 by 2, I by 2, which is equal to 15. So I dash will be equal to your 15 amperes. Okay, 15 amperes. So it means that in order to find the value of the Vs, we have to apply KVL in this particular loop. So on applying KVL, we can see that Vs will be equal to the voltage drop across 1 ohm resistor plus the voltage drop across 4 ohm resistor plus the voltage drop across 5 ohm resistor. It means that Vs will be equal to 1 into 30 plus 4 into 30 plus 5 into your 15. So that is coming out to be your Vs will be equal to, so on solving it, we are getting the value of the Vs to be equal to 225 volts. Okay, so I hope it is clear how we are approaching the problem. Okay, so now let's solve the second problem. Okay, so in this problem, we need to find the value of the V. So in this particular electrical circuit, we have given two networks, N1 and N2, and they are connected by the help of the resistors, and we need to find the value of the V over here. Okay, so as you can see, in order to find the value of the voltage V, we need to first evaluate the value of the current. We need to first find the value of the current I, which is flowing from this 3 ohm branch. Okay, let's say the current that is flowing from 2 ohm resistance is your I1. Okay, and the current flowing from 4 ohm resistor is your I2. Similarly, the current flowing from 3 ohm resistor is your I3. So in order to find the value of V, we first need to find the value of I3. Okay, so as you can see, we can apply a KCL at this particular common node. Okay, so as you can see, all the currents I1, I2 and I3 are all entering to the same common node. It means that I1 plus I2 plus I3 will be equal to 0. So it means that I1, so the value of the I1 will be equal to the voltage across 2 ohm resistor 6 divided by 2, which is equal to your 3 amperes. Similarly, I2 will be equal to 16 divided by 4, which is equal to 4 amperes. Okay, so I1 plus 3 plus 4 is equal to 0. It means that the value of the I1 will be equal to minus 7 amperes. So in order to find the value of the voltage V, we can directly apply Ohm's law. So on applying Ohm's law, so V will be equal to I3 into R. So that will be equal to minus 7 into 3, which is equal to, so V will be equal to minus 21 volts. Okay, so I hope it is clear how we are approaching this particular problem. So that's all for today, guys. I will see you in the next tutorial. Okay, thank you.